Let's now look at chemical bonding. So the question should be, what is chemical bonding and why do atoms participate in a chemical bonding? Now, whenever atoms get to combine, that is what we call chemical bonding. So atoms combine with each other by forming of bonds, and this combination is what we call chemical bonding. So chemical bonding is simply the coming together of atoms forming bonds. So a bond is more like a connection. Now the question is why? Why should atoms get to come together, or why should atoms get to bond? So atoms of some elements have incomplete filled outermost shells. So some atoms in the outermost shell, the electrons are not enough, they are incomplete. Because of this, the atoms are unstable. Okay, because the outermost shell is not completely filled up, the atoms are unstable. And because they are unstable, this makes the atoms to be more reactive. And because of this, they're going to react with each other in order to acquire full outermost shell like those of the noble gases. Because they are unstable and they are reactive, they are going to react to make sure that they also become what stable. And if they react, they are going to achieve what is called the noble gas configuration. Why are we saying noble gas? Noble gas are group 8 elements. And in group 8 we said the valence is 0. That is, when you are finding the valences, you look at the group number. And then you are going to remove from 8. So I'm going to say 8 minus, in which group is this? Group 8. 8 minus 8 is 0. Meaning that the valence of group 8 elements is 0. If the valence is 0, meaning they don't combine because they're already stable. Okay. Now, because we're talking about all these, the number of electrons in the outermost shell of an atom is closely related to the valence of an element. So the valence is simply the the number of electrons in the outermost shell. For example, when you have got X, let me use groups. You have got group 1 elements, group 2 elements, group 3 elements, group 4, group 5, group 6, 7, and 8. Group 1 elements have got a valence of 1. Group 2 elements have got a valence of 2. Group 3 elements have got a valence of 3. Group 4 elements have got a valence of 4. Group 5 elements have got a valence of 3. Group 6 elements have got a valence of 2, of 1, and then of 0. So as you are going like this, you are just going to get this, and that is going to give you the valency. But when you reach at group 5, to find the valency, you are going to remove from 8. So it is going to be 8 minus a group number, this is group 5. This is going to be 8 minus 6. This is going to be 8 minus 7. That is how we find this. So this is valency. Now, when you're talking about the number of electrons in the outermost shell, that is called the valency. So this one has got 6 valence electrons, meaning we have got 6 electrons in the outermost shell. Okay, this one has got 7 valency electrons, but it has got a valency of 1. Valence electrons are electrons in the outermost shell. The valency is just a combining power of an atom or element. So having understood that, let's look at the types of bonding. And the first one we're going to talk about is ionic bonding. When you're talking about ionic bonding, this is a bonding that happens between metals and non-metals. Always. And this kind of bonding, it involves the losing and gaining of electrons. This is very important for us to understand. This losing and gaining of electrons. For example, we can pick any non-metal and a metal. We can pick a metal sodium and react it with a non-metal chlorine. Now, what are the valencies of these? sodium is in group 1, meaning that its valence is what? Correct, it is 1. What of chlorine? Chlorine is in group 7. What is going to be its valence? That's good. The valence for chlorine is also 1. Why? Because it is in group 7. To find the valence, you are going to say 8 minus 7. So when this one wants to form a compound, you are going to have sodium chloride. They are going to swap. This one which is on chlorine comes on sodium. This one which is on sodium comes on chlorine, like that. But 1 over 1 is simply 1, so we don't even show that. We just write it like this. So this is a formula for sodium chloride, meaning that one sodium atom comes together with one chlorine atom to form sodium chloride. Now what is going to happen? We need to look at the number of protons of each of these atoms. If you consider first sodium, sodium has got 11 protons. Okay. And then if we consider chlorine, chlorine has got, okay, this is 17 protons. So these are neutral atoms, meaning that if we want to write the electron configuration starting with sodium, the electron configuration, remember, is 8. So the electron configuration is going to be 2, comma. The second shell can be filled by only 8 electrons. Third shell by 1 electron. We looked at this if you've missed it out. And then chlorine, electron configuration is going to be, the first shell can only have 2 electrons. The next shell, if you put 2 here, it can have 8 electrons. 2 squared is 4, times 2 is 8. So I've got 2 plus 8, that is 10, but we have got 17. How many are remaining? We are remaining with how many? 7, like that. So because of this, the last shell for chlorine is supposed to have 8 electrons, but we only have 7. So which one should be easier? Is it to lose these 7 so that we remain with these 8 in the outermost shell, or we gain only 1 electron to make it 8? It is easier to gain 1 electron than to lose the 7. So that is why it's going to gain 1. Now for sodium, which one is easier? Is it to gain 7 electrons to make it 8 in the outermost shell, or to lose this one so that we remain with this 8? Losing 1 is easier, so that we are going to lose 1. So this one which has been lost here is the one that is going to be gained here. So how does chemical bonding happen? So now we are going to show how the reaction is going to happen. So firstly, you have got sodium. Remember the electron configuration, we've said 2, 8, 1, and then for this one is 2, 8, 7, meaning that this one has got 3 shells. Now mostly when you are writing this, you are only interested in the outermost shell. Okay, I'm going to show everything. The first shell has got 2 electrons. Second shell has got 8 electrons. 1, 2, 3, 4. You put them in a pair of 2, 2, 6, 7, 8, and then we are remaining with the last shell, which has got only 1 electron. So this is going to react with what? With the chlorine. So this is sodium. And I'm going to write the electron configuration 2, 8, 1. Sodium, this one has got 2. And then this one has got 8. Now I'm using the same, we shouldn't use both dots. So for this one, I'm going to use dots since the other ones have used crosses. So I'm going to put a dot there and a dot here. 1, 2, 3, 4, 5, 6, 7, 8. And then we're remaining with 1. And it has got 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this is chlorine. It's going to be 2, 8, 7. So when these react, you are going to see the formation. So we're going to have the sodium. Now for the sodium, we have lost this electron which is here. When we lose that electron, I'm not going to show this shell, so it is now only going to have what? 2 shells. Now these two shells which have remained, I'm only going to show this shell, which is, I'm not going to show the first one. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now this has become what? It has become sodium plus. Why? Because it has lost one electron. You need also to show now its new electron configuration. It is now 2 comma 8. This one is no longer there because it has lost that. And then you have got a chlorine. The chlorine in this last shell, it has gained one electron. Wow, I didn't even write it well. It is not supposed to have two electrons in this shell. It is only supposed to be one. Okay, because there are only 7 there, so we are only supposed to show 7, not 8. So because we have got one which is lacking, I'm going to also only show the outermost. 1, 2, 3, 4, 5, 6, 7. Now the eighth one is a cross. Why is it a cross? It is the one which has been lost. This is the one which has come here. Okay, so this is now going to be chlorine with a minus because it has gained. The electron configuration is 2 comma 8 comma, this was 2 comma 8 comma 7, but because it has gained 1, it is going to be 2 comma 8 comma 8. So the charge here we're going to put on top a plus, we're going to put on top a minus. So this is how you show ionic bonding. Those which have gained, you need to put them in these brackets, and then you need to show the charge there. You also need to show the new electron configuration. All right, let's see one more example and then we go to another type of bonding. Let's say you're talking about the coming together of magnesium and chlorine. When magnesium reacts with chlorine, how is the reaction going to happen? So magnesium is in group 2, it has the valence of 2. Chlorine is in group 7, it has got a valence of 1. So we're going to form magnesium chloride. So what you are going to see in this case is the magnesium, the 2 on magnesium is going to come down here, and then the 1 on chlorine is going to come here. But for 1 we don't show it. So I'm just going to write this. This is the symbol for magnesium chloride. Now again we need to know the atomic number for magnesium, and the atomic number for magnesium is 12. Atomic number for chlorine still 17. So let's write the electron configuration for magnesium. The first shell is supposed to always have 2. Second one can have a maximum of 8. So we have used up already 10. From the 2 of how many are remaining? 2. So that is going to be 2 comma 8 2 comma 2. Then for this one, we already saw the electron configuration is 2 comma 8 comma 7. So what you are going to see is we need what? 1 magnesium with 2 chlorines. So I'm going to put a magnesium here. Now I'm only going to show the outermost shell. So here is the outermost shell for chlorine. It has, for magnesium I mean, it has got only 2 electrons, 1 and 2. I'm going to write this electron configuration. So it says magnesium electron configuration is 2 comma 8 comma 2. Remember, I've only showed these 2. I'm not showing these which are inside. And then this magnesium is reacting with 2 chlorines. I'm also going to only show the outermost shell. Outermost shell has got how many? 7 electrons. I'm going to use a dot for the chlorine. 1, 2, 3, 4, 5, 6, and 7. I'm also going to write the electron configuration for chlorine. It's 2, 8, 7. So what you are going to see is when these react, remember we are bringing together how many? 2 chlorines according to the formula. So if you can't write the formula, it will be very difficult for you to show even the bonding. You have got 2 chlorines. So what you are going to put is 1 chlorine, you are going to put it on one side. So first we are going to have the middle. Then we are going to have this side. We also have this side. Okay, so what you are going to see is you only have one magnesium, so the one which is just alone is going to be on the middle. So what is happening to the magnesium? Which one is easier? Is it to gain 6 electrons to make it 8, or to lose the 2? It is losing the 2. So we're going to lose these 2. So the outermost shell is going to remain with the 8 electrons. So I'm going to show 8 in the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. So the new electron configuration, we need to write it. Magnesium is now going to have 2, 8. And then the chlorines, remember this one has lost 2 electrons. So one of those electrons it has lost. First, let me write the electron already present, which are the 7 of them. So one electron which the magnesium has lost is going to come here. And then the other one, remember it lost 2. So also here 1, 2, 3, 4, 5, 6, 7. And then the other one is also going to come here. So the chlorine, now the new electron configuration is going to be, remember it was 2, 8, 7, but it has gained 1. So it is going to be 2, 8, 8. Even this chlorine is 2, 8, 8. Now, this one has what? Has lost 2 electrons. And when something loses, it becomes negatively charged. So it's going to be what? 2. I mean, when something loses, it becomes positively charged. 2 plus. This one has only gained 1 electron, so it is going to become minus. This one has also gained, it is going to become minus. So this is the reaction that happens between magnesium and chlorine. This is how you need to show it. If you want, you should put chlorine here, magnesium there, and also chlorine there. But these are have charges. So this is magnesium 2 plus, this is chlorine minus, this is chlorine minus. So that is how you show when it comes to ionic bonding. Alright, so the next kind of bonding is a covalent bond. Now, how does covalent bonding happen? Well, just different from ionic. Covalent bonding happens between non-metal. So I've got a non-metal plus another non-metal. Don't have any metal here. And instead of losing and gaining, you have got a sharing of electrons. So there's no losing and gaining, there's only a sharing of electrons here. And we're going to look at 2 examples. Let's consider water first. So what happens is this. In water, H2O, firstly you have got hydrogen and oxygen which are reacting. Now, just on the non-metals, you need to know that some of these non-metals, hydrogen always exists with a 2. Oxygen always exists with a 2. Fluorine, chlorine, nitrogen, these non-metals always exist with a 2. But sulfur you can even see it just like this. But for these, they always exist with a 2 down. In other words, they are diatomic gases. You need to know them. So every time they are reacting, they will always come like that. So when you have got hydrogen with a 2 coming together with oxygen, these are all gases. This is going to produce now water. Is this balanced? No. You can see we've got 2 hydrogens, you also have 2 hydrogens, but you have got 2 hydrogens only have, 2 oxygens, you only have 1 oxygen. So to balance the oxygen, you are going to put a 2 here. You don't balance by putting a number down, you always put in front. And don't fit a number here. Alright, so we have made now 2 oxygens and also 2 oxygens. But you see, the hydrogens have become the 4 of them. So we also need to put a 2 here. So this is a balanced reaction between hydrogen and oxygen to form water. So you can say this is a gas. These are state symbols. This is also a gas. This can either be liquid water or gaseous water. In this case, let's talk of liquid water. We'll put liquid there. Now I'm only interested in water itself, H2O. So what is going to happen is when an hydrogen comes together with oxygen. So you see that for every one water molecule that you are going to form, for every H2O that you form, what is happening? You are bringing 2 hydrogens with only 1 oxygen. Okay, two hydrogens with one oxygen. So what happens is you are going to have two hydrogens according to the formula that you are able to see. Now, hydrogen has got only one proton, meaning its electron configuration is only one. Oxygen has got 16 protons. The electron configuration is 2, 8, 6. So we're going to have oxygen here. Let me write this electron configuration: 1, 2, 3, 4. I'll put here 5 and then here 6. I'm not showing these which are inside because the electrons which participate in a reaction are only outermost electrons or valence electrons. So the 6 of them. Remember, we are bringing what? Two hydrogens to form one water molecule. So we're going to have one hydrogen this side, one hydrogen this side. And we can see that each hydrogen only have what? Only has one electron. So one electron from hydrogen is going to come here. The other hydrogen also brings one electron there. You can see they are sharing. So it's also important to put a key. So we are going to say a dot is meaning an electron that is coming from hydrogen, and then a star is meaning an electron coming from the oxygen. So in this case now, the electron configuration for oxygen is going to be 2, 8, 8. Why? You can count 1, 2, 3, 4, 5, 6, 7, 8. So it's now stable. And then hydrogen, those which only have one electron, they're supposed to have a maximum of 2 electrons in the atmosphere. 1, 2. So it is stable. This is 2 and this is also 2. So when you fill an atom with 2 electrons in the atmosphere for it to be stable, that's called duet. Those electrons which only have one shell get stable when they fill the outermost shell, which is only one shell with 2 electrons. But these which get stable when they fill the outermost shell with 8 electrons, we say octet. Okay, so that is it. So these are the types of reactions which we have. We've got a covalent bond, the ionic bond. Let's first also consider how the carbon dioxide is formed, because carbon is a non-metal and oxygen is a non-metal. So we already know the formula for carbon dioxide, CO2, and we know that carbon, it has got electron configuration of 2, 4, and then oxygen has got electron configuration of 2, 8, 6. Okay, like that. Now, question is, how is the reaction going to happen here? Well, to be able to see how the reaction is going to happen, we are going to get, you can see that one carbon reacts with 2 oxygens. So let's have one carbon on the middle here. And then we are going to have 2 oxygens. One oxygen, let's put it this side. Let me just make the carbon much bigger. Okay, we have got 2 oxygens around the carbon. Now remember, carbon has got only 2 electrons in the outermost, 4 electrons in the outermost shell. Oxygen has got 6 electrons in the outermost shell. What you want to make sure is that this should be 8. This should also be 8. And remember, we have got 2 oxygens. So this is oxygen. This is carbon. This is oxygen. So how is that going to happen? Now carbon dioxide is a bit trick. There we get to write the electron configuration. So we need also to be very good the way we are going to draw it. So I'm going to put it like this, and then for the oxygen, I'm going to make it enter more like that. And then also here, Okay, like that. So what you're going to see is these four you are able to see here. The two I'm going to put it here, and then the other two I'm going to put them here. Okay, and then for the auctions, they have got six. So from the six, two I'm going to put them here, and then four have remained. The four which have remained, I'm going to put them outside. And then same here, the two I'm going to put them here. The four which have remained, I'm going to put them outside, like that. So this is auction, this is auction, this is carbon. So if you count now the electronic configuration for auction, I mean the number of electrons without atmosphere for auction, we've got now 2, 4, 6, 8. So auction is balanced. And then carbon 2, 4, 6, 8. Carbon is also balanced. And then for the other auction 2, 4, 6, 8. So they are all balanced now. So this is how the reaction gets to form. And that's how they come together. So the electronic configuration for auction is now 2, 8, 8. This one is now 2, 8. This one is 2, 8, 8. So there, that is how we form the reaction between carbon dioxide. And the last one we're going to look at is just nitrogen gas. Or nitrogen molecule. So how is this going to be? So when we're talking about nitrogen molecule, firstly we need to know the proton number for nitrogen, and the proton number for nitrogen is 7. So this one is formed from when a nitrogen reacts with a nitrogen, and each of these have got a proton number of 7, meaning that the electron configuration for each nitrogen is going to be 2, so we have 2. Now how many are remaining from 7? We're remaining with 5. So we're going to put those 5 here. This is the electron configuration. So we're going to have one nitrogen with 2, 5, 1 there, 2, 3, 4, 5, reacting with another nitrogen. I'm going to put circles 1, 2, 3, 4, and 5. So when these two come together to form nitrogen molecule, what you are going to see is this comes like that, this comes like that. So for this one is going to bring, these three are going to come together like that, and then they are going to be here 1, 2, 3. They are going to be inside. So 2 have remained. Those 2 which have remained, I'm going to put them outside here. And then the other one, these 3 also are going to come together 1, 2, 3. The 2 which have remained are going to be outside. So if you count 2, 3, 4, 5, 6, 7, 8. So for this one, it is balanced. Same with the other one, it is also balanced. So this is how nitrogen molecule is when it gets to react. So this means that it forms a triple bond. That's why for nitrogen molecule it is written like this, because you have got 6 electrons which participate in a chemical reaction. But for carbon dioxide, you saw that we had 2 electrons which are bonding. We had something like this. 2 are coming here and like that. So for carbon dioxide, we have got a double bond in it. So I'm going to say carbon, double bond with oxygen this side, double bond with oxygen this side. But for water, you only saw it was like this. So there's no double bond there. So for water, you only have H, oxygen this side, oxygen is this side. So water has got only single bonds, carbon dioxide has got double bonds, nitrogen molecule has got triple bonds. So thank you so much for having been present at this time. Stay blessed.